Hi guys, welcome to Vedant Education, where we solve math, science, and engineering problems for GATE and IES aspirants. If you have not subscribed to our channel, please go ahead and subscribe to our channel below. So today I have another problem for you from electromagnetic theory from GATE 2007. This is a paper of electronics and communication from 2007, and the question number was 19. So here is the question: a plane wave of wavelength lambda is traveling in a direction making an angle 30 degree with the positive x-axis and 90 degrees with the positive y-axis. The electric field of the plane wave can be represented as. So we have to find the expression for this electric field. So in general, the electric field, the expression for the electric field of a plane wave is given as this E naught. This is also a vector right now, and you have the phase term, which is e raised to j omega t minus k dot r, where k is the k vector and r is a vector. So let's just draw the schematic which is given in this problem that says that the wave is traveling in a direction that makes 30 degrees with the positive x-axis and 90 degree with the positive y-axis. So let me just draw this. So what we have here is, let's say this is the x axis, and since the wave is traveling with respect at 90 degrees with the positive y-axis, I will say that the axis coming out of this plane of the paper is the y-axis. So the y-axis is in this direction. That makes this as z. So this is a negative z, this is positive z, this is positive x, and this is negative x. So what we have here is a positive x direction in this case, and the wave is traveling like this. So this angle is 30 degree. So the traveling direction is the direction of the k vector. So this is the k vector. So what we will do right now is first write down the expression for this electric field in terms of the k vector. So let's just expand this k vector for this given problem. So the k vector in this case can be given as k naught, which is the magnitude of this k vector, and if you resolve it along the two directions, which is z and positive x, we get the k as k, and we know that this angle is 60. So if you resolve it along these two directions, so this is k naught cos 60 z cap plus k naught sin 60 x cap. We know that k naught is the magnitude of the k vector is given by 2 pi by lambda, and hence this becomes k equal to 2 pi by lambda 1 by 2 z cap plus 2 pi by lambda root 3 by 2 x cap. So we found out what the k vector is. The r vector here in this case is given by z cap plus x cap. Okay, so the k dot r vector can be written as k dot r is equal to, so it's pi by lambda and z cap plus root 3 pi by lambda. It's just z, not z cap. So this is the k dot r vector. So if you put this expression into, plug in this expression into the expression of this electric field, you will get the phase term. Also you have to know that since this is a plane wave, the electric field is perpendicular to the k vector. So the electric field can be perpendicular to the k vector. So it's either this, or it can also be in the y direction, since it's also perpendicular to the k vector. Since in the given solutions there is only y vector which is present, that means the electric field is perpendicular to this k vector and it's in the y direction. So the total electric field, once we plug in all this information, can be given as E equal to y cap E naught, where E naught is the magnitude of this electric field, raised to j omega t minus root 3 pi by lambda x minus pi by lambda z. So this is the final expression, and you can see that this is the option A here. So in this case, the electric field expression is given by option A, and A is the right answer. Thanks for watching Vedant Education. Please go ahead and subscribe to our channel if you have not done so, and also check out the description below for the books I recommend for studying for GATE and IES.